Okay, so we're going to take a look at numbers 1 and 2 from the Extra Practice with Polynomial Graphs packet. All right, so first thing we want to do, it says the directions are to write an equation in factored form for each polynomial function shown below. Okay, so in order to do this, we have to look and say, well, what are my zeros? So we have a 0 right here at x equals -2. And we have another one right here at x equals +5. Okay, so they want us to write a function, they want us to write an equation for the function in factored form. So first of all, since it's a function, we're gonna put it in function notation, f of x equals. And we know that the zeros that we have right here help us lead to our factors, right? If we have a 0 at x equals -2, that would correspond with a factor of x plus 2. Okay, we're gonna change the sign here. And then since we have a 0 at x equals +5, we're going to have a factor at x minus 5, right? We change the signs. Now, there's a couple other things we have to take into consideration. If we look right here, see how the graph comes down and bounces off the x-axis? Didn't we learn that that means there's multiplicity here, okay? So what's happening is, because there's multiplicity, right? There's a multiplicity of 2. We're going to have 2 factors of x plus 2. So I'm going to put a squared on that. And if we look over here, same thing. Okay, it's bouncing off the x-axis. So there's multiplicity of 2. So there's 2 factors of x minus 5. So let's put a square on that also. Okay, now the other thing we have to take into consideration is we don't know what this leading coefficient is, right? Like it could be a 1, it could be a 5, it could be an 8, it could be lots of things. So what we have to do is we have to figure out what this leading coefficient is, because that's going to be part of our equation, okay? Do we have a number here other than a 1? All right, so let's try it out. What we're going to do is, for right now, I'm going to call that leading coefficient C for coefficient, okay? We don't know what that is. And we're going to solve for C. So this is how we do it. You can pick any point on the graph other than your x-intercepts. You can try it out. If you try to plug in the coordinate of an x-intercept into this function, you're going to run into a dead end. So I'm going to actually avoid that. If you want to try it to see what I mean, you can. But I'm going to pick, usually the y-intercept is a really good point to pick, okay? This point right here. I'm going to change colors now, okay? The coordinates of this point are 0, 80. Okay, so the coordinates of this y-intercept right here is 0, 80. So this is my x value, and this is my y value. Now, if we look at our equation over here, okay, we said the x value at this point is 0. So wherever I see an x, I'm going to substitute in a 0. All right, so right here, I'm going to have a 0 plus 2 squared, and I'm going to have a 0 minus 5 squared. All right, now, the y value is 80, and we know f of x is representing y, right? Isn't that another way to represent a y? So I'm going to replace this f of x with the y value of this point that we chose from the graph. So I'm going to replace that with an 80. And then I'm going to bring down my equal sign, and I'm going to bring down the c. So basically what we're doing is we came up with a general format for this function, but we need to find the leading coefficient. Okay, we're solving for this variable. So I took any point on the graph that was like, clearly it went through the point 0, 80. Like over here, like we don't know the exact coordinates at this point. Over here, like we can estimate, but we don't know the exact coordinates at this point. This, we can clearly see that it goes through 0, 80. So I'm using this point to substitute in values for x and a value for y, and we're going to use that to solve for c. Okay, so let's do it. So I'm going to bring down this 80, and I'm going to bring down the equals c, and then 0 plus 2 is 2, and 2 squared is 4. Okay, so this, I'm going to change to a 4. All right, now over here, 0 minus 5 is -5. And -5 squared, right? -5 times -5 is positive 25. So I'm going to replace this with a 25. Okay, so now let me bring down the 80 equals c, and then 4 times 25 is 100. Let's think about it. We're solving for c. If we want to get the c all by itself, if this is c times 100, if we want to get the c by itself, wouldn't we just divide both sides of the equation by 100? Okay, so this cancels off, and I'll bring down the c. And then 80 over 100 simplifies to 4/5 or 0.8, however you want to write it. Okay, I'm going to write it as a fraction. I'm going to write it as 4/5. But if you prefer to write it as a decimal, 0.8, you can do that. All right, now let's go back to our original format of the equation. Now we want to keep it in function notation. So I'm going to write f of x. I'll go back to pink again. So f of x equals, well now, look at this. We know what c is, right? Didn't we just solve for c? We know this leading coefficient is 4/5. So I'm going to replace the c with 4/5. Okay, and then here, I'm going to leave this in terms of x. So I'm just going to take this and bring it down and take this and bring it down. So I'll bring down the x plus 2 squared, and I'll bring down the x minus 5 squared. Okay, this is the equation of this function. And if you want to check, you can always graph it in your calculator. I'm actually going to do that real quick, and I'll show you that it matches up. Okay, so this is not going to be the easiest to see because the lighting isn't the best. But what I did was I went to y equals on my calculator, and I took this equation, and that's, believe it or not, I know it's hard to see with the shadows, but that's what that says. Now, if I were to hit graph, it wouldn't look exactly like this because, think about it, right now, my window is set up, so the x value goes from -10 to +10, like it does here. But my y value in the calculator is usually only set up to go to a max of 10. We need to go up to 200. So I'm just going to change the window. If I hit window, I'm going to just change the, again, it's really hard to see, but this says y maximum. Instead of that being on 10, I'm going to change that to 200. Okay, oops, sorry. And now when I hit graph, it should look something like what we see on the screen there. Yep, look, same graph. So our equation right here checks out. Okay, so now let's take a look at number 2. Oh, okay, well, I'm going to have to delete, I guess, this picture because that didn't come off for us. All right, so let's do the same thing here that we did in the last example. All right, so first thing we're going to do is we're going to determine our zeros. So we have a 0 right here at x equals -2, and we have a 0 right here at x equals +1. Okay, so we could write f of x, that's function notation, equals, now again, we don't know the leading coefficient, so I'm going to use a c for right now. And if we have a 0 at x equals -2, wouldn't the factor that corresponds with that be x plus 2? And since it's bouncing off the x-axis, we have multiplicity, okay? There's 2 of those factors, so let's put a square. Now here we have another 0 at x equals +1. So the factor would be x minus 1. Now I'm not going to put a square on that one because it's not bouncing off the x-axis. It's going right through it, so there's no multiplicity. Okay, so now what we have to do is we have to determine what our leading coefficient is. We need to solve for c. So I'm going to pick any point on that graph that's like super clear that you can definitely tell what it is. And most of the time, the easiest point to use is your y-intercept. So the coordinates of that, although I just colored red over it, is 0, 4. Okay, what I'm going to do is, since this represents our x, I'm going to plug in 0 wherever I see an x, so I'll plug in a 0 for this x. And I'll plug in a 0 for this x. Okay, so I'm replacing the x's with zeros. And since this represents my y value, we know another way of saying y is f of x. I'm going to replace this f of x with a 4. And now this, I'm going to bring the c down. This is the equation we're going to use to solve for c. Okay, so let me bring down the 4 equals and the c. And then right here, 0 plus 2 is 2, and 2 squared is 4. And then 0 minus 1 is -1. Okay, I'll bring down the 4 equals c, and 4 times -1 is just -4. And if we want to get the c by itself, since this is c times -4, the opposite of multiplication is division. So we'll divide both sides of the equation by -4. So the -4's cancel. I can bring down the c. And since 4 divided by -4 is just -1, we now found the value of c. All right, so now I can go back to my original format of my function up here. And I want to write the function in terms of f of x and x. So I'm going to rewrite f of x, and then equals, now in place of this c is -1. So you could either write -1, or if you just want to put the negative symbol, you can, because if you're writing stuff after it, you don't have to actually put the 1. If you want to put -1, go for it, okay? And then I'm just going to bring the rest of this down. So I have an x plus 2 in parentheses being squared. Oop, that 2 didn't come out. And then I have an x minus 1 in my other parentheses, okay? So this is my final answer. And that, by the way, is a 2, even though it doesn't look like it. And again, if you prefer to write -1 instead of just negative, that's fine as well. Now, if you want to check this, you could do the same thing I did in my calculator, except look at this. We can use a standard window this time. We can just use x min of -10, x max of 10, y min of -10, y max of 10, and plug in this equation. All right, I'm going to do that real quick just to check it out. Okay, so I did that, and check that out, okay? This picture matches this one. And look, it goes to the point 0, 4. Same y-intercept, same x-intercept, same shape, same graph.